Hello, this is a video for Math 2-3 explaining some of the properties and characteristics about matrices. This is part one of the videos. There's a lot more to learn, but this is the basics. This is a matrix. Some of the things that we should see about the matrix: it's got square brackets on the outside of it. It's got 6 individual numbers arranged inside of it. Each one of these numbers is in what's called a cell, kind of like a prison cell or a cell from biology. It means that it's separated from the other ones. That's a 3, and that's a 4, and that's a 6. Obviously, it's never 346. The square brackets on the outside show us that this is a matrix, and it helps us tell one matrix from another. The size of the brackets doesn't really make a difference, but the size of the brackets doesn't really make a difference. It's the number of cells within it that makes the difference. Along the horizontal here, horizontal is this direction, by the way. These are called rows. In this case, the matrix that we were looking at had 2 rows. 2 rows of 3 numbers each. In each of the rows, there were 3 columns. The columns are the ones that go up and down. Sometimes when I can't remember which side has the columns, the side or the top, I just remember that columns are the things that hold the ceiling up, and they go up and down like this. Then I can figure out which ones are the rows. So rows go across, they're horizontal. Columns go top to bottom, they're vertical. Here's a row. This row has the numbers 3, then 4, then 6 in it. This is called row 1. Column 1 would be right here. So the 3 is in row 1, column 1. Row 2 is the 2, the 0, and the 5. Yes, you can have a 0 in there for a cell, but you can never ever have an empty cell in a matrix. Sometimes you could have a variable in one of these spaces. When we start using matrices in equations, the way we use just plain old everyday numbers, we'll see that we can replace some of these cells, or sometimes even all of these cells, with variables. So in this case, row 2, column 2 would be this number right here, the 0. So to look at that again, each one of these cells inside the matrix has what we call an address. The address always has 2 parts. It always has a row and a column. The row always comes first. So in row 2, column 1, so that's row 2, column 1, where row 2 and column 1 intersect, that's the address that we're looking for. So row 2, column 1 is a 2. You can't get them mixed up. That's very, very different from row 1, column 2. Row 1, column 2 has the number 4 in it. Obviously, they're different. Size is the next characteristic that you need to know about for a matrix. All matrices have size, and knowing the size of a matrix is important for a lot of the calculations we're going to use for it. So the size of the matrix, which is also known as the dimensions of the matrix, always goes rows first and then columns. So here, since we have 2 rows, there's row 1 and row 2, and 3 columns, 1, 2, and 3, the size of this matrix would be called a 2 by 3 matrix. This is really important, so I'm going to stress it again. This matrix size is always, 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 always the row first, then the column, row by column. So this matrix is a 2 by 3. If you get those backwards, you'll have serious problems and you won't be able to do the calculations that we're going to learn later. Like with this, is this matrix the same as the other one? Well, it has all the same numbers in it, doesn't it? And instead of a 2 by 3, it's just a 3 by 2. So in some ways it is the same matrix, just sideways, but for all of our reasons that we're going to have, all of the calculations that we're going to do, all of the ways that we're going to store information in matrices, this is a different matrix than the other one. So this is a 3 by 2 matrix. Even though the same numerals are in here in the cells, the fact that they're arranged differently, the rows and the columns are switched from the other one, it is different. You cannot just take a matrix and turn it on its side and use it. You can't just switch the rows and the columns. There are, I admit, circumstances under which you can do that, but we're not going to worry about it in this class. When you have a unit later on that uses matrices for other things, maybe that will come up, and if you take a college class on this stuff called linear algebra, you will see a lot more of that. But for now, just know that the matrix, the way it's written, you can't change it. You can't switch it around to make your calculations easier. It just doesn't work. So some things to keep in mind. All matrices must have square brackets around all the cells. You have to have those square brackets there. If you leave them off, you just have, well, some numbers. It's not a matrix that you can work with. There has to be clear spacing between the cells. If you can't tell one cell from the other, you're going to think that a 2 and a 3 might be a 23, for example, and that will mess up your calculations. So make sure that you use that your matrices are neat enough that you use clear spacing between the cells so that you can tell one from the other. Size always has to be listed rows first, then columns. If everybody does it that way, we'll always be able to tell a 3 by 2 from a 2 by 3 because they can look very similar. So we always use rows first, then columns. There has to be a number, or sometimes a variable, in every cell. You cannot have blank spaces in your matrices and work with them. They just won't work right. This is important. You cannot ever switch the rows and the columns. Ever. Well, not in this class anyway. There are times you can do it, but you can't do it in this class, so don't even try. That's the end of part 1 of the matrix video. Subsequent parts will deal with addition, scalar multiplication, multiplication of two matrices, using matrices to represent real-world data, and what happens when you can't work with the matrices. There's lots of circumstances where you just can't add, subtract, or multiply matrices, and for some reason, you can never divide them. Anyway, this video is now over.